Alright, hi everyone, welcome to the first lesson for Mechanics 1. So before this, I hope that you have go through the previous video which we discussed about the whole syllabus or the content that you will learn in Mechanics 1. So as mentioned, we will kind of reshuffle the topics in this syllabus. So that's why we'll start with topic 2, which is known as Kinematics of Motions in Straight Line. Alright, so before I move into the learning outcome, right, I would like to do a very quick introduction of this topic. So meaning what are the four main components that we will go through together under this topic. Okay, so the first one, which is also what we will learn in this video, which is kind of like a very basic thing, is for you to understand some of the important concept here, which is the distance. Okay, so you can write in your handout as well. So the distance. So if you have distance, then the next one you have speed. Oops, I'm sorry. Okay, speed. Then after that we have displacement, velocity, and also the last one is acceleration. Okay, so after today's session, then for the next lesson, we'll be looking at two graphs. So the first one is known as the displacement time graph. So sometimes we'll just write it as DT graph. Okay, so displacement time graph. Yeah, I guess this concept are not very, you should have heard this before during your IGCSE or even SPM. Okay, so the second one is velocity time graph. Okay, or it's also known as the VT graph. All right, then the third one, we will be learning about the constant acceleration. So under constant acceleration, we have actually five formula that involve displacement, initial velocity, final velocity, acceleration, and also time. So all the five formula is also called as the Suvat formula. Okay, so you can just remember this name. Alright, so the five formula is actually for constant acceleration. So for non-constant acceleration, we have what we call as variable acceleration. So for variable acceleration, meaning that the acceleration will kind of keep on changing in the situation given. So under these cases, right, you will need to use the technique of differentiation and integration that you have learned in Pure Maths 1 in all these cases. So the techniques involved wouldn't be like that difficult, like what you learn in P3 is all those basic one that you learn in P1 only. So even like for differentiation, meaning the product rule, the quotient rule is not involved as well. It's just like a very basic one. Okay, so this is like the whole idea for this topic. So for this session, we'll be looking at, as you can see in the learning outcome, we'll be looking at the concept of distance, speed, displacement, velocity, and also acceleration. All right, so let's start with the first one, the distance and displacement. Okay, let's start with the first two terms, distance versus displacement. Alright, so distance is a scalar quantity. Okay, so it's a quantity that we use to measure the total length of a path. So which means if let's say you are traveling from your home to your school, then the distance will be the total length the vehicle takes for you to reach the school. Alright, so it has only magnitude. Alright, so we always say that when we measure a length, there's no negative length, right? So we wouldn't say like this pen is negative 5 cm. So that's like similar to distance, because distance we talk about the total length as well. Okay, so whereas for displacement is going to be a vector quantity. Okay, so I hope that you still remember the difference between scalar and vector that you have learned in P3. So displacement wouldn't give the total length, but displacement will give the position. Okay, so give the position of an object relative to a fixed reference point. So normally this fixed reference point will be called as the origin. Alright, so a simple idea is that you can imagine if let's say this is point A and this is point B. So maybe for me to travel from A to B, right, the total path, the total length that I have traveled is actually from here to here to here to here. So this is the distance. So when we talk about displacement, then it can be like here. Okay, so which means what is the position of an object if let's say here the A is the fixed point. Okay, so for displacement, it has both magnitude and also direction. All right, so both of them are actually equally important. There's no it's not like magnitude is much more important than the direction, which means that both gives the meaning of displacement. So we can imagine that if let's say I have this maybe here, this is A and this is B, and this is C and then this is D. So you can imagine if let's say I try to connect them together. All right, so if let's say this is 20, and also this is 15. All right, so obviously we know that in terms of distance, AB is going to be equal to BC, right? Okay, so when we talk about displacement, AB and BC is not the same, okay, because they are in the different direction. So this is in terms of distance. So if let's say it's in terms of displacement, so which means AB and BC isn't the same. So it's the same thing as well if let's say I try to change this into 20, so which means all these three distance are the same but the displacement are all different. Okay, so that's the idea. So in this course, right, all the kinematics that involve, it will be in one direction only. All right, so one dimension. Okay, so the idea is if let's say, right, we are going to take displacement in a given direction from origin to be positive. So an easier one would be if let's say this is the origin, right? So if this is the direction that my displacement is positive, then the displacement in the opposite direction will be negative lah. So that's the idea for one dimension. So which means that we are not going to talk about like this is positive, then how about if let's say I go up or if let's say I go down. So if let's say up and down, then it will be up will be positive, then down will be negative. So we are not going to talk about two dimension like having the x, y. So it's just either you have only x or you have only y or you have only z. So that's what is that meant by one dimension. Okay, so this is negative. All right, so I think that this is kind of easy. So let's try to move on to the second part for speed and velocity. Okay, so in the second part, we have speed versus velocity. So we know that speed is relating to distance and velocity is relating to displacement. Okay, so these are the two ways that we use to measure how quickly an object moves. So similar to distance, so that's why speed is also a scalar quantity. So it has only magnitude. All right, so you should have quite familiar with the formula. So if let's say you have a journey that the object is keep on moving at a constant speed, so meaning the speed doesn't change from the beginning to the end, then you will be able to calculate the speed by using the formula distance divided by the time. Okay, but you can imagine in real life cases, right? So normally you wouldn't have a journey that the speed doesn't change. Okay, so a simple example will be if let's say you drive a vehicle and you want to travel from your home to the school, so you always start your vehicle with a speed of 0. Then after that, in the journey itself, you will have traffic light, you will need to turn left and turn right and so on, right? So the speed will keep on changing. So for non-constant speed, we will always use the idea for average speed. So the it's similar to our speed, but then for average speed, we'll take into consideration for the total distance. Okay, so you must make sure that you are taking the sum of all the distance that you travel, then after that divide by the total time. Okay, so this is for average speed. All right, so next one, we move on to velocity. So this is related to displacement. So that's why it is a vector quantity. All right, so similar to displacement, if let's say it is a vector quantity, so it has both magnitude and also it has direction. Okay, so which mean except telling you how fast the object move, it also tells you the direction of the object. So which means if let's say you have a positive velocity, then meaning that the object is moving to the direction that you assume as positive. So the other, if let's say it's a negative, which means it's going to be a opposite direction. So we are going to look at a simple illustration later by using this example here. Okay, so similar to speed, so for an object that moving at a constant velocity, so you can always get the velocity by using displacement divided by the time. Okay, displacement divided by time. So which means in a short name, then you can always remember V equal to S over T. All right, so it's the same thing if let's say you want to get the displacement, right, then it will be equal to S equal to VT lah. So that's the idea. All right, so similar to the average speed here, for non-constant velocity, we also have average velocity. So average velocity will be equal to the net change of the displacement. All right, so which means what is the changes of the displacement relative to the fixed initial point that you have or the origin that you have. Okay, so the net change in displacement divided by the total time. All right, so in the next part, we are going to use this simple illustration of this person running through and forth in this track of 40 meter. So he's running by using a constant speed, which is 4 meter per second. Okay, so I'll add in this in your notes. So yeah, don't worry about that. So we are going to do a very quick one so that you can differentiate the difference between distance, displacement, and also speed and velocity. Okay, so for distance, so yeah, distance is basically the total length of the how much the object has traveled. So this person has actually traveled 10 meters, so I guess this is easy. Okay, so displacement, it will be the position of that person from the origin, right? So this is our origin and our positive side is going to be the right hand side. So that's why the displacement is going to be positive 10 meter as well. Okay, so this person is running at a speed of 4 meter per second. So that's the speed. So for velocity is also going to be the same magnitude as speed, but one thing that you need to take into consideration is that whether it's in positive direction or negative. Okay, so you see that this person is running to the position to the positive direction. So that's why the velocity will be positive as well. Okay, now this person reached the end point, then after that he actually take a U-turn, then back to this same position. So you can imagine the distance is a total length, so that's why it's going to be go 20 meter, then come back another 10 meters. So that's why he has traveled a total of 30 meter. Okay, but for the displacement, you realize that this person has come back to this position. So that's why the displacement is still going to be 10 meter because it's at the positive 10 meter from the origin itself. All right, so for the speed, because he's running at a constant speed, so that's why it's going to be 4 meter per second as well. So for velocity now, okay, you can see that this person is still at a position of positive displacement. But what is the direction of his motion now? He's running to the negative direction, right? Because this is positive, so which means this is going to be negative. So that's why the velocity will be negative 4 meter per second. Okay, so I hope that you get the idea. Displacement, we talk about where the object is. So it is at the positive side. So velocity, we are talking about the motion. So which means he is running towards the negative direction. So that's why it's negative. All right, so the next one, he reached the negative side. So that's why you can imagine that the displacement will be a negative number, so negative 10 meter. So how about the distance? So he is here, right, at the starting, then go there 20, then come back another 20, then another 10, so which means he has traveled a total of 50 meter. Okay, so for the speed, it still be a constant one, so 4 meter per second. Okay, so how is the velocity here? Is he running towards the negative direction or positive direction? Yeah, so he is at a negative displacement and he's running towards the negative direction as well, so negative 4. Okay, and the last one, yeah, I hope that by this time you have actually grabbed the idea already. So the distance, so 20, 20, then going there 20, another 10, so 70. Okay, so displacement, although he is running, coming back, but he's still at a position of negative. So that's why it's negative 10. So you can see these two person is actually at the same place, but the difference here is that whether they are running, go to the left hand side or go to the right hand side. So that will make a difference in your velocity, but not the displacement. So velocity, because he is running to the right hand side, right, which is the positive direction. So that's why positive 4. So the speed will be still 4 meter per second. All right, so in this picture, yeah, although we don't have a time here, but we can see that for the person here is running at a constant speed, right? So that's why the average speed will be the same, which is 4 meter per second. Okay, so now the question is, what do you think is the average velocity? So average velocity, we talk about the net change of the displacement over the total time, right? So if let's say I assume that at the end of this journey, this person actually come back here. Okay, can you imagine what is the average velocity? Is there any net change in your displacement? So he start at the origin and he ends at the origin. So that's why there's no net change in your displacement. So no matter what is your total time, it's still going to give you 0. Okay, so that's the idea of the difference between the speed and also the velocity. All right, so now we'll be looking at two examples before we move on to acceleration. All right, so let's look at these three simple example here. So I believe that you can always go through by yourself. Then after that, you come back to the video to check it. So yeah, I don't mind about that. All right, so a car travels 9 km in 15 minutes at constant speed. Find the speed in meter per second. Okay, so the only thing that I think is that you need to be careful here is that the units here lah, because you are having it in kilometer and minutes, so make sure you change it to meter and also second before you find the speed. All right, so for the speed, we know that it's going to be the distance divided by the time. Okay, so the distance in this question, yeah, I'm going to just write down the formula for the example so it's easier for our discussion. So for distance, it's going to be the 9 km here, right? So make sure you change it to meter. So it will be multiplied by 1,000 so that from km to become m. So 15 minutes and then multiplied by 60 seconds. So you can get second, so meter per second. All right, so that's the idea of how you can always check your answer. So you can get 9,000 and divide by 900. So you'll be able to get the answer 10 meter per second. Okay, so question 2. A cyclist travels at 5 meter per second for 30 seconds and turns back, traveling at 3 meter per second for 10 seconds. So find her displacement in the original direction of the motion from her starting point. Alright, so for this question, if let's say you find it a bit confusing, then what you can try to do is you can try to draw it out. So it means now you have this origin, right? So this cyclist actually travel at 5 meter per second for 30 seconds. Okay, so when he reach here, then after that he turns back. So he turns back. So we're not sure how much, but it's going to be 3 meter per second. So for another 10 seconds. All right, so this is the origin here. Okay, so now let's try to find the displacement. So we know that if let's say we have speed equals to distance divided by time, so which means distance will be equal to the speed multiplied by time. All right, so if let's say is we talk about displacement, then it will be v equal to st, right? So velocity equal to displacement divided by time. So that's why displacement is equal to velocity multiplied by time. All right, so for us to calculate that, then you will need to do it. To find what is the first distance, then after that you find the second distance, then you might want to find what is the total displacement here. So that's the idea. Okay, so for displacement, so since we always try to assume that the first direction, normally we'll try to take it as positive, so that's why like to the right hand side is going to be the positive. So for us to calculate the distance for the first journey, then it's going to be 5 multiplied by 20. sorry, multiply by 30, yeah, velocity multiplied by the time. Then after that, yeah, since it's in the opposite direction, right? So that's why minus, then another 3 multiplied by 10. Okay, so you'll be able to get 150 minus 30. So this is how you get to the answer, 120 meter. Okay, so it's the same thing. You can imagine if let's say this is a distance that longer than this one, right? Then you'll be able to get a negative displacement, which makes sense also by using this diagram. Okay, so the next one, it will be number 3. Okay, so a cyclist spends some of his journey going down here at 15 meter per second. So let's try to do this. So going down, okay, so it's 15 meter per second. Then after that, take a rest. Okay, then after that, go up again. So when it goes up, then it's 5 meter per second. Okay, so this total journey actually took him 1 minute. So let's try to write in seconds. So which means it's going to be 60 seconds lah. So in total, he traveled for 540 meter. Okay, so what is the information that you can get here? Yeah, perhaps you want to try to think about it. Okay, so he traveled a total of 540 meters. So you can imagine the journey going down here plus the journey going up here, it will be equal to 540, correct? So what is the distance when he going down here? So we have 60 seconds in total, right, for the time. So for the first half, meaning when he going down here, let's say we try to assign a variable. So this is the time that he spent going down here. So let's say this is a t. So can you tell me what is the second part here? So if let's say he spent 1 minute, which is 60 seconds, so which means the second half, it will be 60 minus t. Okay, so that's why for us to form a equation by using the total of the distance, then it will be 15 multiplied by t. Okay, the velocity multiplied by the t, and then plus the 5, and then multiplied by 60 minus t, then it will be equal to 540. Okay, so yeah, you might have a question where do we need to put positive and negative since this is going downwards and this is upwards. So you don't need to do that because in 1 minute he traveled 550. So that's why the 550 is more like a distance than a displacement. Okay, so that's why. So we have 15t and then plus 300 minus 5t equal to 540. So we can get 10t will be equal to 240. So that's why our t, it will be equal to 24 seconds. Okay, so it means that for the first half, he actually take 24 seconds. So for the second half, it's another 36 seconds. So you can always try to multiply them together and you should be able to get 540. Alright, so I guess the example here is pretty direct and simple. So yeah, it's basically an introduction video for you to just make a very quick recap on what you have known previously in IGCSE, no matter you are taking physics or not. So just a brief idea for you to understand what is that meant by the displacement, the distance, the speed, and the velocity. Okay, so now let's try to look at the last part, which about the acceleration. Alright, so at the last part of the lesson, we are going to talk about acceleration. Yeah, so we know that speed is the rate of change of distance and also velocity is the rate of change of displacement. So acceleration measure the rate of change of velocity, okay? So it tells us how quickly the velocity of an object is changing. So having an simple example here, so if let's say this is the two object, okay, so both of them start is at rest, okay, at the beginning, so that's why the velocity is 0. So after 10 seconds, so if let's say the first object reaches a velocity of 20 meter per second, then the second object here reaches 40 meter per second, so which means that the second object here is having a higher acceleration. Okay, so in other words, the higher the acceleration, meaning the greater the change in velocity in the time given. Alright, okay, so for an object that moving at constant acceleration, so which means that the change of the velocity is constant, All right, so it's going to be equal to the change, the acceleration is going to be equal to the change in the velocity and divide by the time. Okay, yeah. So if let's say an object has constant acceleration a, initial velocity u, and also final velocity v, and you measure them in a time given which is t. So to find the constant acceleration, we can always use the formula of a equal to v minus u. Okay, so v minus u is basically the change in velocity lah. So meaning what is the final velocity that the object reach, then what is the initial velocity that the object start with. So you divide by the time. Alright, so where your initial velocity, the final velocity, and the acceleration are all measured in the same direction. Okay, so I hope that you have no problem with that. Yeah, so you must understand that having a high acceleration doesn't mean that it has a high velocity. Okay, so which means a simple illustration, if let's say this is a plane, right? Aeroplane. So if let's say this aeroplane keep on moving with a constant velocity of 100 km per hour. Okay, and this is another car here. So this car start from 0 km per hour. Then after that, after a period, then he is now traveling at a speed of perhaps just 20 km per meter, sorry, per hour. So within these two, right, so although this aeroplane is with a high velocity, but as what I mentioned, it's moving at a constant velocity, so which means from the starting at the end, the velocity is remaining at 100 km per hour. So there's no acceleration involved here. So which in other words, there's no change in velocity for this aeroplane. So although this car is traveling with a lower speed, but because of it travels at a velocity which is zero, then after that it achieved 20 km per hour. So that's why there is an acceleration involved here. Okay, so I hope that you can get the idea that having an acceleration doesn't mean that the object is traveling with a very high velocity. It just means that the velocity change over the time. Alright, so an increase in velocity is a positive acceleration, and the decrease in velocity, it will be a negative acceleration, or normally is often termed as the deceleration. Okay, so now we'll be looking at this four simple example here, so that to make sure that you understand how the vector component in acceleration look like. Okay, so we know that acceleration is the change of the velocity, so that's why it involves magnitude and also direction as well. So having a positive direction, which means it will give us positive lah, then negative is negative. Okay, so if let's say in the first case, right, this object traveling from 20, then after that it reaches 40. So the change in speed is actually increasing, right? Okay, so yeah, a simple idea is that when you use 40 to minus 20, then you can get a positive answer. So the change in speed is going to be positive as well. So which means this object actually move faster. So I guess the first one, we have no doubt here the acceleration will be a positive acceleration as well, because the object is moving towards the positive direction and is moving faster and faster, so that's why the change in velocity should be a positive number. So for the second one, if let's say the speed is reducing from 40 to 20, so you can imagine if we are using the final velocity to minus, sorry, the final speed to minus the initial speed, then what are we going to get? We are going to get a negative number, right? So we also know that the speed decreasing, meaning the object is slowing down. So that's why the acceleration here will be a negative number. So it's in a positive direction, but the change of speed is negative. So that's why the acceleration is negative. So in this case, this is also called as deceleration as well. Okay, now we are looking at the more confusing part, which we discussed about the negative direction. Okay, so similar with the previous two cases, let's try to look at the idea of acceleration from 2 points, so the direction and also the magnitude part, which we talk about the change in speed. So you can imagine that from 20 to 40, so the speed is actually increasing, so which means that the object is actually speeding up. But what happens here is that you can see that although the object is speeding up, but because of it's in the negative direction, so that's why the acceleration will be a negative number as well. Okay, so you must remember that a positive acceleration doesn't mean that the object is speeding up, and having a negative acceleration also didn't mean that the object is slowing down, because it involves the changes in direction as well. Okay, so the same thing for the fourth case here. So we can see that from 40 to 20, so the change in speed is actually decreasing. So that's why it's a negative number. Okay, so you can imagine that if let's say the change in speed is negative and is towards the negative direction, the acceleration will eventually become positive. Okay, so you can always try to imagine it in a form of mathematically also. So which means that you can imagine if let's say this is negative direction, right? If we try to change the speed into negative velocity, then what will happen? It's going to be negative 20 to negative 40, right? So you can see that although the number is getting bigger, meaning the magnitude is getting bigger, but in mathematics, so negative 20 is eventually smaller than negative 40. So that's why when you use this number to minus this number, right, you are still getting a negative number. So that's why the change will become a negative one. So similar to this, so although this is negative 40 to negative 20, so the vehicle is actually slowing down. But in mathematics, negative 40 is going to be lower than negative 20. So that's why when you use negative 20 to minus negative 40, you are getting a positive number. So that's why you will have a result of the acceleration is positive. So always remember that having a positive acceleration doesn't mean that it's speeding up, and having a negative doesn't mean that it's slowing down. It just basically tells you that how is the direction of the speed and how is the direction of the velocity. Is your acceleration happen according to the motion of the object. All right. Okay, so now we are looking at this very simple formula here. So if the acceleration is constant, the average velocity is simply going to be the average of the initial velocity, okay, and also the final velocity. All right, I hope that it makes sense to you. Yeah, so which means if let's say the rate of change of the velocity is a constant one, so which means the average will be just the initial plus the final, then divide by 2 lah. So that's why the average velocity, we can always write it in the form of 1 over 2 multiplied by u plus v. Okay, so initial velocity u and the final velocity v. Alright, so from the previous lesson, we also know that displacement is equal to the velocity multiply t, right? Multiply time. So the s is equal to vt. So you can imagine if let's say we are using a average velocity, so we can use the formula just now to substitute inside the v here, and what do we get? We can get a formula which tells us that s will be equal to 1 over 2 u plus v and then multiplied by t for us to find the total displacement. All right, so yeah, that's a simple formula here, and in the next two lessons we are going to look at the Suvat formula, which we will look into deeper for this formula and also the other four formula. All right, so now let's try to look at the two example before we end the lesson. Alright, example 4, a parachutist falls from rest to 49 meter per second over 5 seconds. Find her acceleration. Alright, so I guess this is pretty direct. So acceleration will be equal to the change of the velocity, which means the final velocity minus the initial velocity, then divide by the time. So that's why you have 49 minus 0 and divide by 5. So you will be able to get 9.8 meter per second square. Okay, yeah, you can imagine that this is the unit of meter per second, right? Then when you divide by s, then you are going to get s negative 2 lah. Okay, so now let's try to look at number 5. Okay, a tractor accelerates from 5 meter per second to 9 meter per second at 0.5 meter per second. Yeah, so you can always try to write down the information by using the symbol. So u, the initial, is going to be 5. The final velocity is 9, and this is the acceleration, which is 0.5. So what you are finding is the distance. Okay, so find the distance, which is the s. Okay, so if you can recall for the previous formula, right, we didn't actually touch the part where we have the 5 formula that connects all u, v, a, s, t together. So that's why we might need to use the basic formula to actually help us to solve this. So we know that to find s, right, we have this formula that tells us that s will be equal to 1 over 2 u plus v multiplied by t, right? So 1 over 2 u plus v, then this give you the average velocity, then multiplied by the time, so that you can get the displacement. So in this case, since you do not have the t, so which means we need to get the t from the information given here. So that's why by using the formula of a equal to v minus u over t, so we'll be able to get 0.5 equal to 9 minus 5 divided by t. Alright, so 0.5 t will be equal to 4. So from here we can get that the time is actually 8 seconds. Alright, so after you get this, then which means now we can try to substitute back into the formula here. So which means s will be equal to 1 over 2 u plus v multiply t. So we can substitute 1 over 2, u is 5, v is 9, and also t is going to be 8 seconds. So just by using your calculator, and you'll be getting your answer 56 meter. Okay, so I hope that this lesson can give you a brief idea for the some basic term, yeah, which mean the distance, the displacement, the speed, the velocity, and also the acceleration. And after this, we are going to look at the other parts in a more detailed way. Alright, so that's it for today's session. Please spend some time to finish your homework. If you have any question, just feel free to approach me personally. Alright, so see you, thanks.